Solving inequalities. Notice the following words: less than or equal to, greater than or equal to, and equal. Those are all words that are used for inequalities. Equal is only used for equations. We will match the following terms with the following symbols. Please copy down as I match. Less than or equal to, greater than or equal to, and equal. We will compare the four sets of numbers using the symbol. The first symbol will be used to indicate that 8 is greater than 5. We use the greater than symbol. For the next example, -2 is greater than -6. Again, we use the greater than symbol. For the next example, -8 is less than 7. So we use the less than symbol. And for the fourth example, 3 is greater than -4. Remember, all positive numbers are greater than negative numbers. When solving inequalities, you solve them just like an equation. The only difference is that it has a different sign in the middle. There's a special rule about inequalities. Flip the sign when dividing or multiplying by a negative. Example number 1. 5x is less than -30. You solve this just like an equation. And you get a solution that states x is less than -6, meaning x can be any number that's smaller than -6, such as -7, -100, and -22. Example number 2. Subtract 5 from both sides to get the x by itself. Our solution is x is greater than or equal to 6. Example number 3. Get the x by itself. You come up with x is greater than 27. Example number 4. -10x is greater than 100. Notice I divided by a -10, therefore I will have to flip the inequality symbol. Example number 5. Step 1 is to add 13 to both sides. Step 2 is going to be to divide by -11 on both sides. Because I'm dividing by a negative, I will have to flip my inequality symbol. Our solution is x is less than or equal to -2. Example 6. I subtracted 7 from both sides, and now I will multiply both sides by 4. In this example, I divided by a positive, therefore my inequality symbol stayed the same. Notice in example number 7, you have variables on both sides. Solve it like an equation with variables on both sides. In the final step, I will have to divide by a -2. Remember, when you divide by a -2, or any negative, you must flip your inequality symbol. Example number 8 incorporates distribution. Step 1 was to distribute the 9 into the x and into the 2. Then, I subtracted 9x from both sides. I will now add 12 to both sides. Because I'm going to have to divide by a -5, I will have to flip my inequality symbol. Resulting in x is less than or equal to -6. In example number 9, again, my first step will be to distribute. Notice, after I subtracted 4x from both sides, I have a negative in front of my x. That indicates that when I get to resolving the x, I'm going to have to divide by a negative, therefore I'm going to have to flip my symbol. Here is the step where I'll have to flip the symbol, because I'm dividing by a negative number. The following 4 are a quick example of one-step inequalities. Notice the steps are the same as they would be for a one-step equation. You did not have to worry about flipping the inequality symbol because there were no negatives to divide or multiply by. The next example is a two-step. Solve it like you would a two-step equation. Subtract 12 from both sides, giving you 3x is less than 3. Divide both sides by 3. and you get x is less than 1. For the next example, make sure you combine like terms before you solve. Notice I combined 4x with negative 2x, which gave me 2x minus 4. I then added 4 to both sides to give me 2x is greater than or equal to 24. Then I divided both sides by 2 to get my solution of x is greater than or equal to 12. This next example looks quite difficult. However, it will just require some extra steps. We'll start with distributing. After you distribute, you look for like terms. There are like terms to be combined on the left side. There are also like terms to be combined on the right side. Now, solve. Your solution comes out to be x is less than or equal to 0. Your next example requires you to remove fractions. Remember, to remove fractions, you multiply each term by a common denominator. In this case, the common denominator for 5 and 2 is 10. First, multiply 10 times 4/5. You will do 10 times 4, which is 40, and 40 divided by 5 is 8. Then you will multiply 10 times 3x. 10 times 3x gives you 30x. Bring down your less than or equal to symbol. The next multiplication will be 4x times 10, which is 40x. And the last multiplication will be negative 1/2 times 10. Negative 1/2 times 10 is negative 10 divided by 2, which is negative 5. Now that you've removed your fractions, you can solve as usual. Get your variables to the left side and the constants to the right. Notice, you will get negative 10x is less than or equal to negative 13. Divide both sides by negative 10. Because your answer is fractional, leave it as a fraction. Notice, however, I will have to flip my symbol. The final example will require me to get rid of the denominator 3 by multiplying both sides by 3. Now, I will add 7 to both sides. Divide both sides by 4. You come up with x is greater than or equal to 10.